3 for solving systems of inequalities. And the question here is which is the graph of the system of inequalities y is greater than or equal to 4 over 5x minus 1/5, whoa, and y is less than or equal to 2x plus 6. So I'm just going to go ahead and just write this over here real quickly. Y, it's really small the way it came, so 4 over 5x minus 1/5. Oh, yikes. Well, that's a fraction, not cool. And then y is less than or equal to 2x plus 6. Okay, so we need to figure out which one of these graphs will represent that. And wow, okay, so let's think about this for a second. Okay, which inequality actually looks simpler? And you know, when it comes to slopes, you definitely want a fraction for a slope. Okay, but you know what, this has a fraction and we can really make this a fraction. You remember how to do that? We could just take this and just put this over 1. Now it's a fraction, right? Easy. This actually tells us where to start. So on the y-axis, is it easier to start? All right, let me just write this really quickly. This is the y-axis where we start. Is it easier to start at 6 or at negative 1/5? It's definitely easier to start at 6. So how about if we actually start here and we can start eliminating things by looking. So here we start at 6. All right. Our slope means we're going to be going up by 2. This means we will be going by right by 1. Okay, this implies two things. This implies the first thing is that which direction are we shading? Well, for that you have to know what sign it is. It's a less than sign, so we're going to be shading below the line. Okay, and then the second thing is what kind of a line are we making? Are we making a dotted or are we making it dashed? So if you remember from the other videos, if you saw them, a solid line underneath implies a solid line on the graph. So something that looks like this, nice solid line. So let's go here. Okay, first thing is we start at 6. Okay, so look, we start at 6. And here we can't go up, right? So let's just try to go down. So if we go down to left 1, that seems to work, right? Down to left 1. This seems to be working right here. Okay, so that's good. As we're going up, okay, so remember you read a graph from left to right. Okay, left to right. So as we're going from left to right, this is increasing. This is good. So this is a shade below the line. It looks like we are shading below the line here. Look at that. That's definitely being shaded below the line. And it is a solid line. So this right here might be an answer. Okay. Over here, we're starting at 6 as well. Okay. But we're supposed to be going up to the right one. Since we can't do that, this should have actually been down to the left one, right? So we should have actually been here. So this is not a solution. We automatically eliminate that. Here, okay, why isn't this going to work? And if you're thinking it's because it doesn't look the same, great, but mathematically it is because this starts at negative 6. Okay, we want something with a positive 6. So this is gone. So it makes sense that the last one would also be the same graph. So we start at 6, we go down 2 to the left since we can't go up to the right. But notice how if we read from left to right here, you probably already noticed what the issue is that the shading is actually above when our inequality says that we need to shade below. So this would not be a solution. We don't even need to go through this hard part here. We can just immediately know that that's our answer choice. So the answer choice would be 1. Okay. All right. So here's another example, kind of like what we did a while ago. I like to like mix up the examples so that if you are the kind of person who's watching through the videos, it's not like I just show one thing and then I show 2 examples like it, and then you kind of like think to yourself, oh, I really know how to do this because I've just done 2 examples. So I'm just switching around all the time. So here we're solving a system of inequalities. We have 7 over 2x minus, oh, whoa, look at, this is definitely a much harder one, right? 7 over 3y is greater than 14. And then we also have y is less than or equal to x over 2 plus 1. All right, first thing is, when you're graphing, and I know that looks like a hard thing to graph, you have to think to yourself, like, what do you know? And we know that it must be in y equals mx plus b form. Okay, definitely don't have that here. Absolutely not. First of all, the y needs to be by itself. The y is not by itself. So the way we do that is we're going to take the variable as well as the coefficient. This is known as the coefficient, the number in front of the variable, and the sign, right? All of these is one package. We're going to leave that. We're not going to touch it. We'll leave it right there. And instead, what we're going to do is we're going to move this 7 over 2x, this piece. We move this to that side. Okay, how do you do that? So the way that we can do that is we can subtract 7 over 2x on both sides. Okay, and don't panic too much because we don't have to combine this. Remember, we only combine terms if this had an x, then I could subtract 14 minus 7 over 2 because they both share that variable. But this doesn't, this is just 14, regular number. This is negative 7 over 2 with an x, so these can't be combined. So down comes this piece right here, this box, right? So set negative 7 over 3y is greater than. So the way you write this technically doesn't matter, but we're going to try to keep it the way that we have it here with the mx plus b. So we're going to write negative 7 over 2x plus 14, all right? And to get rid of a fraction, there's many different ways to do this, okay? The way that I'm going to do it might be a little bit different because let's say we had 2y is greater than like 4x plus 8. Totally random example. So this is a random example, has nothing to do with this problem. How would you get y by itself? You would just divide both sides. Okay, and simply enough, you can do that. If you try to divide by negative 7/3 in both of them, that would be pretty challenging, especially if you don't have like a graphing calculator. It's totally possible. It's just a little bit longer. So the way that I do these things is I actually look at the fraction and I multiply everything by the reciprocal. So I will multiply by negative, okay, 3 over 7. This negative, it does not matter where it goes, but because I usually say to keep it on the top, I'm going to just write like this. Okay, I usually always keep everything on top. So now when I distribute this, let's see what's up. Negative 3, right? We're going right across. Negative 3 times negative 7 is 21. 7 times 3 is 21, and the y. Okay, noticing what we're multiplying by, I don't know if you remember this, but if you're multiplying or dividing by a negative sign, this sign actually flips, goes this way. Okay, then negative 3, so here we go, negative 3 times negative 7 is positive 21. 7 times 2 is going to be 14. Okay, remember, when you have the negative, choose one. It's not negative 3 times negative 7 and negative 7 times 2. You gotta choose one place to put them. So I always choose the top. So I do top to top, bottom to bottom. And then negative 3 times 14 is gonna be negative 42. And 7 times, well, there's nothing there. So we can, you know that there's gonna just be a 1 there, right? Put over 1. So this would be 7. Okay, now I know that this looks a little confusing. I would probably take a moment, replay it back, make sure you understand how to do this, because the next step is we're just going to simplify. So 21 divided by 21 is 1, cancels out. If y is less than, this can be reduced by dividing the top by 7 and the bottom by 7. You get 3 over 2. And then here, this becomes negative 6. So this becomes our new equivalent. Very important is that this right here that we started off with is actually the exact same thing as this, just in a simpler way of writing it. So this is what we're going to use. And then the bottom here, notice that this says x over 2. Okay, well, we know that there's a 1 in the front, so we're going to rewrite this as the number, so 1 over 2, then place the x, okay, because these are the same thing, plus 1. But now it's in a simpler way that we're used to seeing. So when we go to graph this now, it might be a little easier. We're going to start here, the first one, negative 6, that's down here. And then positive 3 over 2 means we're going to be going up 3, but you always move to the right 2. Positive 3, always move to the right 2. Positive 3, right 2. And we're going to keep doing this pattern until we get to the edge. Got to the edge, going back to the beginning and reversing the steps. So instead of going up 3 to the right, we're going to go down 3 to the left. Right, that, yeah. Okay. Noticing what kind of sign it is. It's a less than sign. So what kind of line are we talking about? right? If you said it was a dotted, then you'd definitely be correct. This is going to be a dotted line right here. Perfect. All right. We can actually graph this and shade it right now if we wanted to, but I think I always leave that till the end. So then we'll do this other one in clear and blue. Starting at 1. This says we're going to be going up by 1. So going up 1, to the right 2, up 1, right 2, up 1, right 2. Just keep with the pattern. Okay. When you get to the end, where do you go back? Back to the beginning, and reverse the steps. Down 1, left 2, down 1, left 2, down 1, left 2. Keep on going all the way. There you go. And what kind of line is this going to be? Okay, noticing the sign, see that solid line down there? So this is going to be a nice solid line. Here we go. Bam. That is not a solid line. JK. That is a solid line. Un-JK. Yes. Okay. So now let's shade these. I'm gonna shade these with the correct colors. Okay. So here's the purple one. The purple one was this first one, right? So this is a less than sign. So as you read a graph from left to right, just like move your eyes over. As you're going from left to right, the graph is going up. So we're going to shade below that. That would be below it. Okay, you can go right off the thing. That's okay. Make it exaggerated, like all over the place. And then for y is less than a half x, right? Here's the line again. You're going from when you scroll your eyes, right, from left to right. This is going to be below. So here we are here, and you'll start to see exactly where our solutions might be. And it looks like our solutions are going to be right in this area right here. Ooh, that is not cool. Okay, so it looks like it might be and right here in this area. See how I'm just thinking? This is a really thick highlighted marker here that I got going on, but all of these, any of these points is a solution. Tons and tons and tons of them. And that's pretty much it for solving system of inequalities. You just have to know that your solution, okay, is always where they overlap. And what that means is that if I choose any point in the overlap, if I take that point and I substitute it into each of the inequalities, right, each of these guys right here, I'm going to get true statements for both of them. It means like, yes, when I input an x here, I'm going to get an output. And when I compare is 4 less than 12, that's a true statement. Whatever answer you get, it's going to be a true statement. All right, so I'm going to end this here, and we'll move on with the next ones. Let's just see what the next one might look like. It looks like it might just be like a review or something. So we can continue with that.